Hey guys, and welcome back. I'm starting a series of 5 videos on solving equations, and the first one we're going to tackle is solving linear equations. Hey guys, and welcome back. I encourage you to share this note with someone who needs it. In this note, we're going to be talking about solving equations. And you know an equation is formed by putting an equal sign between two expressions. And to solve an equation for a variable x means to isolate the variable x on one side of the equation by any means necessary. I always think of solving an equation as a game where the goal is to free the variable and isolate it on one side of the equation. And the golden rule here is whatever you do on one side of the equation, you do on the other. This first note on solving equation is going to be dealing with solving linear equations, and I'm going to show you how to do that in 2 steps. The first step would be to simplify your equation, which means to free the variable and combine like terms. The second step is to isolate the variable. You would usually do this by doing a reverse order of operation, meaning starting with addition and subtractions before moving into multiplication and division. All right, so our first example here is going to be 7x minus 5 equals 72. As you can see here, the first step is already done because the variable is not trapped into anything like parentheses or fraction bar or anything like that. And all the like terms are already combined on each side of my equations. So now what I have to do is isolate the variable x. I can do that by adding 5 on both sides of the equations. And so I'm going to have 7x equals 77. And then finally, I'm going to divide both sides by 7, which will give me x equals 11. And that will be done for this particular one. And if you wanted to check your answer here just to be sure, you can see that if you plug 11 into the equation for x, you're going to get 7 times 11, which gives you 77, minus 5 will give you 72. So this works out for my equation. Okay, let's look at the second one here. That's going to be a little bit unusual. This is going to be capital I, capital R, plus capital I, lowercase r, equals capital E. And I'm going to be solving for capital I here. Now, I have this example here just to show you that in math, whenever you have a variable, it really matters if it's lowercase or uppercase, right? You have to make a distinction between them. They are not the same. And so you have to treat them as such. And so in this case here, we're looking to solve for I. Looking at the equation that we have here, during step 1, which is to simplify, the variable I is already freed out, but we still need to combine the like term because I can be found in 2 of the terms here and here. And so if I want to combine that, I'm just going to factor out the I, and then I'm going to have I, open big parenthesis, capital R, and lowercase r, equals to uppercase E. And so then the last thing I'm going to do is step 2, which is to isolate the variable. I can do that here by dividing both sides by r plus r. And so I'm going to get my final answer as I equals to E divided by capital R, lowercase r. And that's done for this one. Okay, let's move to our next example, and let's look at 11x minus parenthesis 6x minus 5 equals to 40. In this case, we're going to start with step 1, which is to simplify, which means to free the variable out of any parenthesis and combine like terms. So since we have parentheses here, we're going to just write it as 11x minus 6x plus 5 equals 40. So here we're just distributing the minus inside our parentheses here. And since minus times minus 5 here gives us plus, we have the plus 5 here. Next thing we do is combine like term. So we have 11x here and 6x here. If you subtract them together, you're going to get 5x plus 5 equals 40. That's done for step 1. Step 2 is to isolate the variable x. We're going to start by subtracting 5 on both sides of the equation. And so that will give us 5x equals to 35. Then finally, divide both sides by 5, and that will give us x equals 7. And that will be done. Okay, so let's look at more advanced cases when it comes to linear equations. So the next example here is going to be x divided by 4 equals to 2 plus x minus 3 divided by 3. So whenever you see a case like this, know that if you have a fraction bar, you want to get rid of it. This is part of step 1, getting the variable x free. Also notice that we have numbers on the denominator here, but this is not a rational equation because there's no x variable in the denominator. So this still counts as a linear equation. And so to get rid of 4 and 3, since those two would make up our least common denominator, our least common denominator is then going to be 4 times 3, which is 12. So what I'm going to do here to get rid of my denominators is to multiply this entire equation by 12. So if I do that, I'm going to get in my next line here, 12x divided by 4 equals to 12 times 2 plus 12 in big parentheses, x minus 3 divided by 3. So I'm going to share 12 to every single term in my equation. Next thing I'm going to do is to simplify it a little bit. So I'm going just to have 3x equals to 24 plus 4 in parentheses, x minus 3. We still have parentheses here, so we're still in step 1, trying to free the variable x. So let's go ahead and remove those parentheses. So you're going to have 3x equals to 24 plus 4x minus 12. And then we can go ahead and move to step 2 and start isolating variables on one side of the equation and leave the constant together. So I'm going to have to subtract 4x here on both sides, which is going to give me 3x minus 4x giving me negative x. And then that will be equal to 24 minus 12, which is 12. And then I'm going to finally divide by negative 1 on both sides, which is going to leave me with x equals to negative 12. And that will be done. Let's look at one more example just to make this sink in. So we're going to have here 3x divided by 5 minus x minus 3 divided by 2 equals to x plus 2 divided by 3. Again, since there's no variable on the denominator here, this is not a rational equation, it's still a linear equation in x. But I'm still going to try to get rid of the denominators here because those are holding x hostage. You cannot move x freely left to right if you have denominators. So we're going to try to get rid of them. And so our least common denominator here is going to be 5 times 2 times 3, which is going to be 30. So I'm going to multiply this whole entire equation by 30. And so doing that would then give me, if I multiply every single term in the equation by 30, you're going to have the first one here. It's going to be 90x over 5. The next one is going to be 30 times, big parenthesis, x minus 3 divided by 2 equals to 30 parenthesis x plus 2 divided by 3. And then I'm going to go ahead and simplify it a little bit. That will give me 90 over 5 is 18. So I'm going to have 18x minus 30 over 2 is 15. 15 x minus 3 equals to 30 over 3 is going to be 10. So I'm going to have here 10 parenthesis x plus 2. And then I'm going to go ahead and free the variable x even further by removing the parentheses. And so that will give me 18x minus 15x plus 45, that's minus 15 times minus 3. That will be equal to 10x plus 20, because 20 is 10 times 2. Finally, I'm going to try to move all the x on one side and move all the non-x on the other side. So basically combining / isolating x here. So I'm going to have to subtract negative 10x on both sides. And I'm also going to have to subtract 45 on both sides of my equation. And so this would finally give me 18x minus 15x minus 10x. That would give me 7x negative. That will be equal to 20 minus 45, which is minus 25. And then finally, I'm going to have to divide both sides here by negative 7, which would give me x equal to 25 negative divided by 7 negative, which would give me x equals 25 over 7 positive. And so with this, I'm going to conclude this first part on solving linear equation. And next time we're going to cover how to solve rational equations since they follow naturally from this step. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.